So, any questions about, for what you guys is page 154, but if you're following along in your outline, it's page 295, even though it's not 12 to 15, it's 10 to 11. Any questions? Now, of course, you have the answers available to you, which means all you're doing is asking me, hey, Mr. Myers, why is that answer blah? Any questions about it? Whoa, almost lost. I did lose my eraser. Ironic. I lost my eraser. It was erased from my hand. Now, seriously though, folks, any questions? Isha. 10D as in donut. All right. The cube root of a real number is a function of the number, right? Okay. So if we were to graph it, we would have to decide which variable was going where, yes? So, what do you think would be the input? The number or its root? You're going to make the number the input? That's cool. So we would put number here, yes? Right? Which means the root is over here. Agreed? Okay. So 1 has a cube root, right? What is it? 1. So if I go input of 1, I have a cube root of 1. Does everyone agree? Everyone agree? Okay. Now, what's the next number that has a cube root? It's 8, correct? So if I go all the way out to 8, I'm going to go up to 2. Does everyone agree? Okay. The next one is all the way out at 27, yes? Then I go up to 3. Everyone cool? Okay. So those are 3 of them. That's enough to prove my point here, yes? Now, if I input a number that isn't 1 or 8, does that number have a cube root? It's an irrational cube root, which goes on forever and ever and ever and ever, right? So I'll ask again, does it have a cube root? Wow, I'm concerned by the fact that this answer is causing trouble. You're very emphatic that it doesn't. Why? It doesn't stop, does it? There's no specific output, is there? Because the decimal goes on till infinity, yes? So you could make the argument that, for example, this number right here, call it 5, it has no actual cube root, does it? Right? So if you're going to make that argument, would you connect these dots? No, because if you input 5, there's no output. Agreed? But if you're going to make, I believe it was Sam's argument, that it's irrational and it's got an approximate root, then we know that the cube root of 5 must be between 1 and 2, yes? So it's somewhere in here, right? Can I use my calculator, hit cube root of any number? Yes. And it'll give me a decimal, right? So if you're going to argue that point, then you would connect the dots, wouldn't you? So it depends on which way you want to argue this, right? Is it if it's perfect cube, can we connect the line? Yeah. If it's a perfect cube, can we connect the line? Does 5 have a perfect cube root? So there would be no output at 5. So I wouldn't connect the line. If I'm just talking cube root, would I connect the line? Yes. Now, I haven't looked at the answer. What did they say? I'm interested to see.
They said yes, it's a function.
Okay, they should be connected. So what they're saying is I can take a cube root of every single number. And it might not be an exact cube root, but I can get it. That's what they're saying. Does everybody understand? It just depends on how you want to read the question. It's a real good question for lawyer balling, isn't it? Right? Because you can say 5's got a cube root. It's, well, in this class, every question is a good question for lawyer balling. In real life, it isn't, but whatever.
Only when Sam's here.
math. So 4 cube root 5 equals, I got a cube root, right? But that number goes on forever and ever and ever and ever and ever. Can I technically put that on a graph? No, because it's not an exact number. But for our intents and purposes, we knew that it would be between 1 and 2, and it is indeed, yes? So if we made this graph, right, and we drew the line and we connected the line, because it would connect on a curve, right? Because we go all the way out to 8 and only go up 1. Then we go all the way out to 27 and only go up 1, right? It would make a curve, agreed? So the reason we would say we connect the dots is because anywhere I go here, I can go up and I can get an output. That would be an approximation. Is everybody with me? That's why they're saying go ahead and connect it. All right? If you change this wording to the perfect cube root of a perfect cube, would I connect the dots? No. Everybody cool? Sweet. Any other questions from number 11? I think it only was number 11, right? Any questions from number 11? Are we cool with number 11? Cool, cool? To quote Jake Peralta, cool, cool, cool? I'm caught up to, I don't have the last episode watch. I watch up to the Halloween one. Everybody cool? Okay. Thanksgiving was funny. Thanksgiving was quite a riot. No. If you guys would be so kind as to turn your page over to, I think it is 160. No, I lied. It's 157 that says linear relations?
Yeah.
Okay. You guys are block C. Okay, see you. Make sure you watch the video. Have fun storming the castle. Okay. We've talked about relations. We've talked about functions. We've dealt with them, yes? All right. Today we are going to specifically speak of a specific kind of relation and function. The linear relation and function, which you guys already know, but it's surprising to you how much you already know. So, when we are dealing with relations and functions, we need to be able to work in 5 different ways to think about them. We need to be able to work in words, ordered pairs, tables of values, graphs, and equations. And believe it or not, you already know how to do all 5 of these. Okay? Some of you may think you don't, but believe it or not, you do. So the first thing we're going to do is we're going to read that question. Pizza Hut charges $12 for an extra large pizza. Each topping costs $1.50 extra. Which one of those 5 have I already understood? The words, right? Because we now know that the cost of the pizza will change with each topping, right? So our words are taken care of. Everybody good? All right, next thing I want to do is make a graph of that. So let's start. If I was going to make a graph, I would need to decide what was the independent variable and what was the dependent variable, right? Because that's how we graph it. What would you say is the independent variable? And I do my independent variables in blue, and I do my dependent variables in red. So what would you say is the don't say it out loud, talk to your neighbor, or think about it quietly to yourself for a moment while my computer thaws. Wait, Josh, I'm going to call on you because I love that your hand is up. Is your hand up to answer me? Is your hand up to say, "Could go bathroom"? Excellent. Keep your hand up then. Okay, hit me, Josh. What do you think is the independent variable? But pizza's not even one of the variables. We're getting a pizza. That's not changing. Variables are things that change. So it can't be the pizza, because no matter what we do, when we call Pizza Hut, they're sending us a pizza. So it has to be something else in there. You want another crack, or do you want to think about it for a minute? You think about it for a minute. Brianna, you say cost is the independent variable. Okay, why? What did you just say? The cost goes up depending on the toppings. So how can the cost be the independent variable? Right. You explained it, right? The independent variable are the toppings. Why, Brianna? Yes. Because cost depends on the toppings. So my dependent variable is cost. That's awesome that happened that way. As a math teacher, I dream about a kid explaining it that way. So I can then say, what did you just say? And then you can do exactly what you just said. Oh, it depends. Cost. Excellent. So I put my toppings down here. And I put my cost over here. Now, what is our scale for toppings? 1.
Oh, okay.
What's the next number that would be on our list? 2. And then what?
3.
And then 4. And we're going to stop at 5. Everybody cool? Because anything more than 5 toppings on pizza is just a mess. Right?
Yeah, 20 toppings.
Okay, everybody cool?
What about pineapple on pizza?
Pineapple on pizza can go away. Pineapple on pizza can take a long walk off a short pier.
Yeah.
Pineapple on pizza is disgusting.
It is.
It's got no place on pizza.
No, it's not.
Wow.
It's not good.
No, it's not. It's disgusting.
Sorry, it's like Xbox and PlayStation.
It's personal preference as long as you're not wrong.
Yeah.
Look forward to the pineapple is the best part.
Okay.
I also look forward to it.
Now, here's where you're going to screw up. What is my y-axis?
12.
The lowest one is 12. Then what?
13.50.
13.50. Then what?
15.
Then what?
16.50.
Then what?
17.
Wrong. 18. All right. Now, here's where you're going to screw it up. The first dot on this graph, if I order 0 toppings, goes where?
12.
At 12. Right there, yes? Is it an open or a closed dot? It is closed because I am able to order a pizza with no toppings. If I input 0 toppings, I get an output of $12. Now, somebody right now always says cheese is a topping. No, it's not. If you don't put cheese on a pizza, you have bread.
With saucy bread.
You have saucy bread,
It's like getting,
which is just like toast.
which is like getting one of those like the breadsticks where you dip it in the pizza, like as an appetizer.
Yes.
Just that.
It's just bread. It's not a pizza until there is cheese. It's still okay to call it a pizza if you have some other or no sauce. But once cheese is involved, you have a pizza. We can argue later. Everybody cool? Where's the next dot go?
At 13.51.
At 1:13:50. Where's the next dot go? 2 and 15. Where's the next dot go? 3 and 16:50. Where's the next dot go? 4 and 18. Is everybody cool? All right. Now, the question becomes this. Is this discrete? Or is it continuous? Don't say it out loud. If it's discrete, no connection. No connecting dots. If it's continuous, we would connect the dots. Don't say it out loud. Think about it for a moment and be prepared to defend your choice. I will start being silent for a moment now. Does everybody have a guess?
Yeah.
Jashin.
It's discrete.
It is discrete. Why?
Because, like, suppose, like, you're a little bit past the dot, you can't get, like a decimal of
Right. I can't say I'd like 0.8 of the pineapples, please. No, you can, but they're going to charge you,
Yeah.
right?
They're gonna charge you $1.50.
Everybody cool? What if I get half a pizza, Mr. Myers? When I go on the Domino's website, I can click half.
You can?
Yeah.
Wow.
Yeah.
But they still charge you.
Why not just get a small pizza?
Okay. Everybody cool? Because one day, Sam, we will do the math and you will see what a robbery pizza really is when you think about square area of pizza between large and smalls. Everybody cool? Everybody good? So it's discrete, so there's no line. Now we've covered words. Now we've covered graph. The next one,
Ordered pair.
ordered pairs. Somebody please tell me,
Domains and range.
what are the ordered pairs of this relation? 0 and 12. What's the next one? 1 and 13 fitty. What's the next one? 2 and 15. And so on. Is everybody cool with that? Please notice we've had nothing new except discrete or continuous, haven't we? Okay.
It's all gonna change.
No, it's really not. The next thing that I put on that list was table of values, which some of you are taught is a T-chart. What goes on this side of a T-chart? Wrong. Wrong. Pardon me?
Copy.
Wrong.
Domain.
Wrong. Wrong. What? In this case, it's toppings. But that's only in this case. I want every T-chart or table of values. Input is getting close.
Output.
Did you want to be recording?
I'm recording. The independent variable.
Dang. I was like, how many words?
No. No, you said dependent. Because remember, cost depends on toppings. And what goes here? Now, you guys are used to those being x and y, because in grade 9, you only talked about x's and y's, yes? But in grade 10, we are talking about comparing any data. Right? So it's dv and iv. Everybody cool? All right. Now, in this case, it's toppings and cost. On a graph, it's still x-axis and y-axis, yes? So what goes here? 0. What goes here? What goes here? 1. What goes here? 13 50. What goes here? 2. What goes here? 15. Everybody good? Now we understand tables of values, yes? So what's the only thing left? To understand it as an equation. Now if we're going to understand it as an equation, then what must be happening?
Algebra.
I must do some math, yes? Right? Now, Brianna, how do I arrive at my dependent variable? I do something to the independent variable, don't I? So every equation that I get must be the independent variable with some math equals what? The dependent variables. Everybody cool with that? Always. No matter what. The math happens to the IV to get us a resultant dv. Right? All right. So we're going to change our table of values slightly because we need to build an equation. Toppings, cost. What is the fewest amount of toppings I could have? 0. What is the cost? $12. Everyone agree? Excellent. What's the next amount of topping I can have? One topping. Do I pay $12? Yes. But I pay more. Plus 150. Agreed? Everyone agree? Okay. What's the next number? Do I pay that $12? Plus how many 150s? No. How many 150s? 2. 150 times 2. What if I get 3 toppings? It's $12 plus 150 times 3. Is everybody cool to there? And I'm going to stop for a moment because I think you're lying. Is everybody good to there? And I'm not going to look at anyone in particular. I'm going to slowly scan the room. And you are all going to feel the heat of my eyes resting upon you for a moment while you lie to me and say you get this.
Woo! I'm very good now.
All right. Now, if you get this, you're going to be able to do what I am about to write down. And I'm going to write it down in green because it is so important it must be written in a different color. What if I ask you, how much will a pizza cost me if I put T toppings on it? An unknown amount of toppings. Brianna?
12 plus $1.50 times
It's better than Christmas.
It is?
It's almost like you guys pay attention. Oh my God. Do you have an equation now? What is it? What is my DV?
12 plus 1
No! What is my DV, Jack?
DV plus
It is cost. And what does cost equal? 12 plus
I can't see.
150 T.
Can't see it.
It'll show up like it always does.
My mind is blown. This is about the most.
Wow. Holy crap. Wowzers. Now, just to be safe, because I still think you're lying.
What?
I was just right between the sentences.
This is hard, man.
4 is 8. Oh, no, it's 12. Ooh, spicy.
Can you tell me the equation there?
Yes.
Every equation is IV, some math, equals my DV, yes? Okay. So my DV here is Y, correct? Y must equal my IV. What's my first IV? 3. Right? What is happening there? Plus 5, plus 5, plus 5. Would a math guy write plus 5, plus 5, plus 5? No. What's the short? 5 times, yes? So I must be doing 5 times my independent variable, yes? Okay. My independent variable is 3, correct? So where does that 3 need to go over here? It's a Y? X, 3. So where does that 3 go? Right there. So I have 5 times 3, which is what?
15.
But I don't want 15. I need 7. So what do I have to do to 15 to get the 7? Subtract how much? Minus 8. Right? So if I had to subtract 8 down here, what did I have to do there? Subtract 8. So what's my equation? Y equals 5x minus 8. Do I check it? course I check it. What's my new x? What's 5 times 4? What's 20 minus 8?
Wow.
I remember that. I remember that trick. Yeah.
What's my x here? 5. What's my x there?
5.
What's 5 times 5?
25.
What's 25 take away 8? 17.
38.
Right?
That's a dead joke.
Okay. Are you really not lying to me? All right. So, okay. So now we got one of these empty boxes here, yeah? If I go to the problem of writing something in a box like this, how important is it? A linear relation is a relation in which there is a predictable and constant change in the dv as the iv changes. Okay, now that doesn't make a lot of sense in words, but as soon as you see it in a picture, it's going to make perfect sense. Everybody cool? All right, so don't bother drawing what I'm about to draw. Well, you may want to. Let's go back up to our graph. As my IV changes, how far, what's the change there? +1. What's the change there? 150. Everybody cool? What's the change there? 1. What's the change there? 150. What's the change there? What's the change there? 150. What's the change there? 1. What's the change there? 150. Can you predict where the next dot will be? Where will it be? 1 to the right and 1.5 up. Where will the next dot be? 2 to the right and 3 up. Where will the next dot be? 4.5, 3 to the right and 4.5 up. Do you understand? Where will the next dot be going this way if we were able to go into negative pizzas?
1 down and 1 for
1 down, 1.5 down, and 1 left. Does everybody understand? That's what makes it linear. The changes, they don't have to be the same, but they have to be repeated. Does everybody get it? And look, please, how it repeats everywhere. +1, +150. +1, +150. Right? The changes are always the same. Everybody cool? All right. Now, there's a little bit of a trick here you need to remember. A linear relation can be discrete or continuous. The only rule it has to have is it has to follow that change pattern, right? You have to be able to draw the stairs. Does everybody understand? It doesn't need a line to be a linear relation. Is everybody cool? Okay. So this straight line is okay. This is okay because I could put a line there. Does everybody understand? Everybody cool? All right. So, let's turn the page over. Let's have a look at a couple of things. Now, we are going to look at graphs and tables of values here. So, let's look at this first one. Is it a linear relation? Well, let's check. What's the first change there? Plus 5. What's this change?
9.
Plus 9. Right now, is it a linear equation? Yes, because there's only been one change. So has it repeated once? Yeah, let's check again. What's that? What's that? Plus 9. Once it repeats, is it linear? How many times must we check?
3.
We must check thrice. Why? Because I can connect any 2 points with a line, yes? That's linear. But what if the third point was way up there? Is that? No. So I must check 3 points. Plus 5, plus 9. Is it linear? Yes, linear. Now I'm going to show you guys something that is going to screw you up. Kids mess this up all the time. Pretend, and you don't have to pretend because I'm actually going to make it happen for you. Pretend pretend that I have technology that works. Pretend that one's not there. Is everybody with me? Okay. So that time I went up by 5, that time I went up by 9, right? That time I went up by 10, and that time I went up by 18, right? Almost all of you on your test are going to tell me that's not a linear relation. 5, 10, 9, 18. No! What's half of that jump? 5. So it would be 10. What's half of that jump? 9, so it would be 50. Everybody understand? What if I told you the next one here was 17.5? What would this number be? 63.5, because I went up by half. Instead of going up by 5, I only went up by 2.5, so I got to go up by half there. Look at you. All that and brains too. Jeez. You better clear your calendar, Riley. All these girls are already thinking. It's the 21st century. I can ask Riley to see a movie. I'll have to wait for him to ask me. But I've asked recently. I hear you guys don't do that anymore. I hear that people don't go on dates to movies anymore. Is this true?
No.
I could not be single. That's like my bread and butter date, dinner and a movie.
It is. It's so easy.
I know. But Jack, you've been in my class before. Is it dinner then a movie or movie then dinner?
Movie than dinner.
Wrong. Movie then dinner. Because if you screw up and you have nothing in common, at least you can talk about the movie over dinner. Movie then dinner. 7 o'clock movie, 9 o'clock dinner. Every time. Although now movies are 75 hours long. So, right? Like, what is up with movies? You can't make a movie under 4.5 hours now. That's why I had to fall asleep for Batman versus Superman. It took forever for the fight. Huh? It was 77 hours if it was a minute. And then it was 77 wasted hours. Because again, the only good part of that movie was Wonder Woman. Yeah, it was.
The best part of that movie was the story.
No. The best part of that movie was Wonder Woman. The best part of any movie Gal Gadot is in is Gal Gadot.
That's why Wonder Woman
This
was
is-
good.
No, Wonder Woman's good because not only did you have Gal Gadot, you had Chris Pine. So at any given second, there was something worth looking at on the screen. All right. What about this one? What's that guy going up by? What? And get dinner and the movie. Yes, I know, in the same place. You don't take your date for fast food dinners.
No, this is what you did. Yeah, you take your
Okay? If there isn't a waiter or waitress coming to take your order and you're on a date, that girl's running. Okay? Ask the girls.
Sarah, is this true?
Picnic dates are different.
I don't know girls now.
Yeah, right. I don't know girls. You're right. I couldn't be single. I'd be so dead. I don't know how to do it, man. All right. So, what's this going up by? 5. What's that going up by? 75. Is it linear? So far. What's that going up by? What's that going up by? 2,925. Nope. Non-linear. Everybody cool with doing this with tables of values? Excellent. Let's do this with, wait a minute, Mr. Myers, that's an equation.
Get pranked.
I don't know how to do that with equation. Sure you do. You make it a table of values. Now, this is something that confuses me as a math teacher. I start a table of values and I write these numbers. And half the class says, how did you know to write -1, 0, and 1? Isn't this the input? Who decides what an input is? We do. When I make a smoothie in the morning, do I know what's in it? Yeah, because I put it there. I choose what went into it. Now, if I chose to put in turnips, onions, and rutabagas, would it be a tasty smoothie? No, it wouldn't. But I would know what went into it. If I gave you a turnip, onion, and rutabaga smoothie, and you took a sip of it, would you go, No. You would only have the output. You can't get an output. You don't get a smoothie unless I put something in the blender. I am choosing to use those numbers. If I say x is -1, what do I put there? -1. So the y value is 2 times -1 plus 4. What is it? I'd ask Carlos too, but he's busy. That would be 2. If I put 0 in, what would it be? 2 times 0 plus 4 would be 4. If I put 1 in, what would it be?
2 times 1 plus 4 is 6.
And then let's check. That's going up by what? 1. What's that going up by? 2. Did it repeat through 3 points? So is it linear? Nice. Now let's look at this one. Mr. Myers, it's another equation. Why you gotta be that way? You just make a T-chart. And then you put some numbers in for X. What numbers would you like to put in for X? Because 1, 2, 3 sounds good to me. When X goes to 1, what is this? 4 times 1 squared minus 1. What's that? 3. 4 times 2 squared minus 1. What's that? 15. 4 times 3 squared minus 1. What's that? 35. Plus 1, plus 1, plus 12, plus 20. Is it linear? Non-linear. Now, because you guys only like to hear about shortcuts, and you are now going to completely forget why this works, because I'm about to tell you the shortcut, what do you notice is the only difference between that equation and that equation? Exponent. Exponents are non-linear. Always. Okay? Well, I'm a bit of a liar. I'm a bit of a liar. I am. Wait. I just thought of something that I've never thought of till right now. Honestly, for true. You can watch the earlier video. I didn't think of this then. And I've been teaching math for 17 years, and I kind of forgot about that. What if I had this? Y equals X. Is that a line? No exponents, right? So it's going to make a line, yeah? If I graph it, y equals X. So when X is 1, what's Y? 1. When X is 2, what's Y? 2. When X is -1, what's Y? -1. And it makes that line. Agreed? Okay. What if I gave you this? Y equals X to the -1.
It's the exact opposite.
When X is equals 1, what's Y? 1 to the negative 1 is still 1, isn't it? 1. Everybody with me? Is everybody with me? Because if x is 1, it's 1 to the negative 1, which means it's got to be 1 over 1 to the 1, which is still 1. Everybody cool? Okay, what if x equals 2? Then it's 2 to the negative 1, which is 1 over 2 to the positive 1, which is 1/2, yes? So when x is 2, y is 1/2. Everybody still okay? So I went over 1 and down 1/2. Agreed? Okay, what if x equals 3? Then it's 1/3, isn't it? So over 1, 1/3, and it's making a curve. So yes, even when it's negative 1, it's still not a straight line. I've never thought of that till today. So yes, every exponent.
Mr. Myers did something.
That's cool. I'm glad we did that. I know you guys couldn't care less, but I'm glad we did that. D, linear or nonlinear? Looks linear, but we have to check, don't we? There's a point right there, yes? If I go up 1, I go over almost all the way, yes? Let's check. If I go down 1, do I go over almost all the way?
Yeah.
So that's linear. Now, here's where we get into arguments. Is E linear?
Yeah. No. Yeah.
That's all it takes, James? That's how convicted you are, or how married to your convictions you are? No! 3 guys say yes. Yes! The sky is green, James. The sky is green.
No. Yes.
Right, okay. Of course it's linear. Why? When I went that way 1 plus 1, how far up did I go? 0. So I went up 0. When I went that way 1, how far up did I go? 0. Does it repeat? So is it linear? Of course it is. What about F? Non-linear. What about G? What about G? Linear. Why? I went 0 side to side. Okay, now, the next thing you have to be able to do is graph by yourself. We already know how to do it. X, Y. What are numbers I can use for X? Anything you want. 1, 2, 3. Great. When X is 1, what's Y? 2 times 1 plus 4 is 6. When X is 2, 2 times 2 plus 4 is 8. When X is 3. Everybody cool? Pretty soon it'll show up. There it all is. Which means, what are my 3 points? 1, 6, 2, 3. Graph them. 1, 1, 2, 3, 4, 5, 6. 2, 7, 8. 3, 9, 10. Agreed? So there's my 3 dots, yeah? Would I connect the line? Yes, of course I could. Because can I not take any number, multiply it by 2 and add 4? Even fractions? Okay, so where would the lines be going the other way? Down 2 and where? 1 to the left. Where's the next dot? Down 2, 1 to the left. Where's the next dot? Down 2, 1 to the left. Where's the next dot? Down 2, 1 to the left. Makes a nice line, yeah? Now, I want to show you guys something a little crazy.
That's really close.
There's a reason. Okay? I'm going to go ahead, I'm going to take, and this almost never works because my machine is so bad. I'm going to draw me a straight line. No, it's not, because my machine is very bad. We've covered this.
It's an almost straight line.
Oh, yeah, there we go. It's screwed up now because I'm not touching the screen.
Nailed it.
Come on, open window. You guys have already written that test.
I have this one paper.
Apparently, I've lost all of my programs. There they are. Okay, everybody cool with my line here now? Right? See how it's giant? Now watch. What if I do x is 1/2? What is 2 times 1/2? 2 times 1/2 is 3. What is 2 times 1/2? 1. What's 1 plus 4? 5. So, if I go out to 1/2, right there, and there's 1/2, agreed? There's a half, there's a half, there's a half, there's a half, there's a half. 1, 2, 3, 4, 5. See? No matter what number I choose, it's going to be on the line. Does everybody understand? What if I chose 1,000,000? It'd be on the line. It would be 1,000,000 out there and 1,999,996 up. Everybody understand? Because I can subtract. Everybody cool? Now, just for fun, we're going to graph this. Is this going to be linear? How do you know? It's got an exponent. So we're going to use 5 numbers this time, and we're going to do 5 numbers on purpose.
1, 2, 3, 4.
We're going to use 3, 2, 1, 0. We're actually going to use 6 numbers. 1, 2, -1, 2, and 3. What is 3 squared?
That's 7 numbers.
What's 3 squared? Minus 3? 6. What's -3 squared?
-6.
No.
-9.
No.
9.
9. What's 9 minus 3? 6. What's 2 squared? What's 4 minus 3? 1. Okay. What's -2 squared? 4. What's 4 minus 3? 1. What's 1 squared? 1 minus 3? -2. What's -1 squared? Minus 3? What's 0 squared? Minus 3?
0.
-3. Wait a minute. What is this insanity?
It's a curvy line.
0, -3. Okay. 1, -2, -1, -2. 1, 2, 1. -2, 1. 3, 6. -3, 6. What do I get? It's actually called a parabola. And you will be dealing with them in grade 11. But, is it a function? Is it a function?
Yeah.
Yes, because a vertical line only touches it once. Is it a linear function? No. All right. You guys work on page 308. Now, it looks like a lot, but it's because there's so many pictures. It's actually not that much work. Page 308 is what it's called, but in your book, it's page 160.
Just 160 or 160?
The assignment, till the next thing in your notes, which is function notation. But remember, you may very well have a quiz very soon. Whoa.
Oh, lazy.
Aight? Yo.